Hi students, our subject is linear control systems. What do you mean by a system? If a number of elements are connected in a sequence to perform a specific function, the group thus formed is called a system. Example, an experiment taking place in a laboratory. In that case, a number of elements are connected together in order to achieve a particular output. So it is an example for a system. Similarly, an industrial plant, a communication satellite orbiting the Earth are some of the examples. Now, what do you mean by control system? When the output quantity is controlled by varying the input quantity, then the system is a control system. This output quantity, the output quantity is the control variable. It is also called a response. And input quantity or input signal is the command signal. It is also called excitation. Now, what is a physical model? An idealized physical system is called a physical model. Then, what is a mathematical model? Mathematical representation of this physical model by using some physical laws. It is called a mathematical model. That means consider let the system is an electrical system, electrical circuit. So by using Kirchhoff's current law or Kirchhoff's voltage law, we can write some equations, differential equations or something like that. So this mathematical representation, it is called mathematical model. And the first step in the control system analysis is to formulate a mathematical model. That means we have to write some equations by using some physical laws. So the first step in the control system analysis is to formulate a mathematical model. Mathematical model is nothing but the mathematical representation of that physical model by using some physical laws. And a physical model is an idealized physical system. Now regarding the classification, there are two types. Basic classification, that is open loop and closed loop control system. Control system can be classified as open loop and closed loop control system based on their feedback path. For open loop system, there is no feedback from the output. It is shown in this block diagram. Input is given to a controller. Depending upon the controlling action, actuating signal is given to plant and we will get some output. It may not be desired output. So example is traffic lights of control system, washing machine, etc. Traffic lights using timer is an example for open loop control system. Now the closed loop system, this is the block diagram for a closed loop system. In this case, there is a feedback from the output to the input. Here there is a reference input. Reference input is the desired output. The error detector gives the error signal, that is the difference between the desired output and the actual output, and it is given to the controller, and corresponding actuating signal is given to the plant. So this is the block diagram for a closed loop control system. Here the example is traffic lights having sensor at the input. That means by using some sensors, it will measure the traffic flow rate, and the controlling action will take place according to the traffic rate. And this is another classification. Basic classification is open loop and closed loop control system. This is another classifications. The first one is linear and non-linear control system. A mathematical model of a system is linear if it obeys the principle of superposition and homogeneity. And what do you mean by the principle of superposition? The principle of superposition implies that consider a system with two inputs, x1 of t and x2 of t, and let the corresponding output, let it be y1 of t and y2 of t. For the linear combination of this input, that is alpha 1 x1 of t plus alpha 2 x2 of t, if the system response is also the linear combination of the individual outputs, that is alpha 1 y1 of t plus alpha 2 y2 of t, where alpha 1 and alpha 2 are constant, then the system is linear. If it obeys the principle of superposition and homogeneity, then the system is linear, otherwise non-linear. Next, time invariant and time varying control system. Time invariant, in this system, the parameters do not vary with the time. But in time varying control system, one or parameter vary with time. Example is motion of rocket in vertical height. By the fuel is consumed after some time, then there will be a change in mass. One of the system parameters is changing. Next is continuous time and discrete time control systems. Continuous time control system, all system variables are functions of continuous time t. But in discrete time control system, the information is known only at discrete intervals of time. Then there is single input, single output system is there. Similarly, multiple input, multiple output system will be there. In single input, single output, only one input and one output. Whereas in multiple input, multiple output, there will be more than one input and more than one output. Lumped parameter and distributed parameter control system. Lumped parameter control system can be described only by ordinary differential equations. But distributed parameter control system, it can be described by partial differential equations. Example is transmission lines. Deterministic and stochastic control systems. Deterministic control system, in that case, the response to the input is predictable and repeatable. But in stochastic control system, the response to input is not predictable and repeatable. Then static and dynamic systems. Static system, the mathematical model is an algebraic equation. That means in an electrical circuit, example is made up of only resistive elements. But in dynamic system, mathematical model is differential equation. That is, example is electrical circuit consists of inductor or capacitor. So this is another classification. Then types of feedback, there will be a positive feedback control system, then negative feedback. Positive feedback plus sign, negative feedback minus sign. And comparison of this open loop and closed loop control system. This control action is independent of the desired output. But in this case, it is dependent of the desired output. There is no feedback path in open loop control system, but in closed loop control system, there is a feedback. And it is easy to design, simple construction. But in closed loop control system, it is complex construction, difficult to design. These are economical in open loop control system, but closed loop control system are costlier. Accuracy is less in the case of open loop control system. There is no feedback, but closed loop control system is accurate. But open loop control systems are more stable when compared to closed loop control system. Closed loop control system are less stable. So this is the comparison. It is an important question for the university exam. Now next topic is Laplace transform. The Laplace transform of a given function f of s, Laplace transform f of s can be defined as integral with the limit 0 to infinity f of t raised to minus st dt. And what is the significance of Laplace transformation in control system? Laplace transformation, by using Laplace transformation, we can transform this differential equations into algebraic equation. Solving of this differential equation, it is time consuming and it is somewhat a tedious work. So by using Laplace transform, we can convert differential equation into ordinary algebraic equation. And after solving this algebraic equation, we can finally transform to get the ultimate solution of the differential equation by taking inverse Laplace transform. And you have to study this table. Now, what do you mean by transfer function? Consider any system. There will be one input and there will be one output. This input, it undergoes some transfer operation in order to get an output. This transfer operation, it is termed as transfer function. And the definition is, the transfer function of a control system is defined as the ratio of Laplace transform of the output variable to the Laplace transform of the input variable, assuming all initial conditions as 0. Remember this term, this part, that is assuming all initial conditions as 0. So transfer function, it is the ratio of Laplace transform of the output to the Laplace transform of the input, assuming all initial conditions as 0. Therefore, G of s is equal to C of s by R of s. Now, what is poles and zeros of the transfer function? Consider the transfer function expressed in this form, quotient of polynomials. After factorizing, let it be like this. K is equal to A0 by B0. Okay. Now, what is poles of the transfer functions? Poles are the frequencies of the transfer function for which the value of the transfer function becomes infinite. That is, s is equal to sa, sb, say up to sm. In this particular expression, if we are giving values for s, sa, sb and up to say sm, then the value of the transfer function will become infinite. They are called poles. Sa, sb up to sm, they are called poles of the transfer function. Similarly, what are zeros? Zeros are the frequencies of the transfer function for which the values of the transfer function becomes 0. That is S1, S2, Sn. Here, if we are giving SS, S1, S2, say up to Sn, then the value of the transfer function will become 0. They are called zeros of the transfer function. So, just for an example, transfer function is given by this expression here. 0 of the transfer function s is equal to -3 and poles 0, -2, -4. But here multiple poles, 2 multiple poles, there will be multiple poles set s is equal to -4, the pole of order 2. And poles are represented by cross mark and zeros are represented by small circle. It is shown in this figure, -3, 0, then 0, -2, -4. Here there will be 2 poles. At -4 there will be 2 poles. Okay, in the next class we can find the transfer function of electrical circuits. Thank you.